Hey guys, it's Ross from Argo Daily here. Going to be taking a look at this programming challenge called grab a random node. What we're asked to do here is to write a function which takes as input a linked list and we return a random value from this list. If you're unfamiliar with a linked list, it's a data structure which consists of nodes, each having a reference to the next node. For example, this node here, the first node has a value of 1 and a reference to this second node. This second node it has a value of 2 and a reference to the third node. And finally, this node has a value of 3 and a reference of null. So this signifies that we're at the end of our list. An important aspect of this problem to note is that we're asked to ensure an equal probability of getting any value in this list. For example, with this linked list, we'd have a 1 in 3 chance of getting any of these 3 values, 1, 2, or 3. An approach you might take here is to make use of an array. Fairly common data structure, going to be in practically all programming language, going to be heavily used, just stores values in different buckets. We utilize this by initially starting out at the head of our linked list, pushing this value into the array or inserting it, and then continue iterating across this linked list until we get to our null value, signifying we're at the end of our list. Once we have our complete array with all values from this linked list, we could then make use of this math.random function. It's going to be in most programming languages as well. Typically, we'll return a float or a decimal between 0 and 1. These values are going to have equal probability to be any value within that range. Once we have this value, we can use it to calculate the random index. We do this by multiplying this float with the length of the output array which we just generated by iterating over our linked list, of course. We'd also be passing this into the math.floor function. This takes a float number and rounds it down because, of course, our index is going to need to be an integer, and we'd be rounding down, of course, because we're going to start counting at 0. In terms of time complexity, we're going to be looking at a lookup time of this array of 1 because we would just be simply accessing an index, whereas our searching or iterating of our linked list is going to have a time complexity of n because we're going to be accessing each element exactly once. So just to quickly take a look at an actual code implementation of the solution we just previously discussed. This is in JavaScript, and it's going to take the input of the head node, so the starting node in our links list. It's going to instantiate an array to store all of our values. It's going to also instantiate this variable current node, which will start as the head node. While this current node is not equal to null, we're going to continually push the value of the current node onto this new array that we initialized earlier, and then we're going to assign current node to the reference to the next node, or current node.next. Of course, we'll break out of this while loop once we reach our final node, because this node will assign this current node to the null value, because of course the last node in our linked list is going to have a reference to null. After this, we will just simply return this value from the array of nodes based on this random value that we generate, or this random index, should I say. A slightly faster alternative approach we could take is to actually calculate this random index prior to accessing the values of the linked list. This still would require us to, of course, iterate over the linked list to actually find the length of it, because this is typically not stored as it is in traditional data structures like an array or a hash map, this sort of thing. Once we've calculated the length of our linked list, we could then generate a random index based on the length of the linked list. And after we've calculated this index, we'll then iterate across our linked list once again, keeping count of the current index we're on compared to the random index we generated. And once we get to our desired index, i.e. the random index we've previously calculated, we could simply return the value of the current node and then break out. So of course we wouldn't need to complete iteration across this linked list. This approach has less memory requirements as we aren't going to be constructing a new data structure to store these values as we did previously. Taking a quick look at the code implementation of this alternative solution, it's very similar to the code we previously looked at. The primary difference here is that we're going to be calculating this node number prior to actually accessing any of the linked list values or iteration or iterating across the linked list. Once we have this node number, we're going to continue looping across our linked list until this node number is 0. Once this is 0, we're going to return the current value stored within the node wrap. Because of course on each iteration we're going to continually minus the 1 from this node number. I mean, alternatively we could just store the current index we're at and continually sum up to this node number, but either approach is valid.